All right, so let's get to it. This is chapter 10. Chapter 10 has some meaty topics in it, I believe. Generic types, traits, and lifetimes. All right. Every programming language has tools for effectively handling the duplication of concepts. In Rust, one such tool is generics. Generics are abstract stand-ins for concrete types or other properties. When we're writing code, we can express the behavior of generics or how they relate to other generics without knowing what will be in their place when compiling and running the code. Similar to the way a function takes parameters with unknown values to run the same code on multiple concrete values, functions can take parameters of some generic type instead of a concrete type like i32 or string. In fact, we've already used generics in chapter 6 with option, chapter 8 with vector, vec, and hashmap, kv, and chapter 9 with result, te. In this chapter, you'll explore how to define your own types, functions, and methods with generics. So just a basic summary here. So what they're saying is that, well, from my understanding, what a generic is, it's a encapsulated, scratch encapsulated. It is a piece of functionality that takes a parameter, but these parameters are not concrete types. They're just general variables that represent concrete types that you pass in. For example, we have vector and hashmap, right? You can have any type within a vector, but you have to be consistent to that type. So you can have vectors of strings, vectors of integers, but that t, at least the one here, just represents that a type is going to be passed in, a type of something. And that's what we're going to learn how to do, I believe, hopefully. Let's get to it. First, we'll review how to extract a function to reduce code duplication. Next, we'll use the same technique to make a generic function from two functions that differ only in the types of their parameters. We'll also explain how to use generic types in structs and enum definitions. The overall summary, we're going to first create a function, figure out how to take out information within that function to create another function that does something very specific. Then seemingly we're going to duplicate that function for two different types. Let's say, I don't know, I32 and U32 possibly. I haven't looked at the rest of the chapter, so I'm not sure. And then we're going to write a generic so we don't have to write that same function twice. At least that's what I gathered. Then you'll learn how to use traits to define behavior in a generic way. You can combine traits with generic types to constrain a generic type to only those types that have a particular behavior as opposed to just any type. So what they're saying here is that we're going to learn generics, and then generics apply to all types of possible concrete types that you can pass in. Strings, integers, yada, 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 the whole gambit. However, if you want to reduce that so your generic functionality doesn't apply to everything under the sun, you can use traits and then have your generic function or generic capability apply to only things that have this specific trait. Finally, we'll discuss lifetimes, a variety of generics that give the compiler information about how references relate to each other. Lifetimes allow us to borrow values in many situations while still enabling the compiler to check that the references are valid. And we've come across lifetimes, I think, once before. Have been mentioned in passing in the previous chapters, but basically telling the compiler how long variables are going to live, and then allowing the compiler to be able to ensure that all of the variables that you're using are going to still be alive when you try to use them. As in, they're not going to be dereferenced and taken away before you get to using them. Moving onward. Removing duplication by extracting a function. Looks like we're going to start with the coding. So, before diving into generic syntax, let's first look at how to remove duplication that doesn't involve generic types by extracting a function. Then we'll apply this technique to extract a generic function. In the same way that you recognize duplicated code to extract into a function, you will start to recognize duplicated code that can use generics. Consider a short program that finds the largest number in a list, as shown in listing 10-1. So that's down here. Let's bring our editor That's already there. Move this over. Cool. Let's see what 10-1 has. So looking at it real quick, we have a let number list equal vect, and then we have some numbers in it: 34, 50, 25, 100, 65. I typed that right? I did. Let the mutable largest equal the first one in the number list. Okay, that makes sense. And then we're doing a for loop, seemingly looping over them, and then trying to figure out which one's the larger, and if it is larger, assign it. So that makes sense. For number in number list. Code block. If the number, I32, is greater than our current largest, then we need to assign our current largest to be equal to that number. And then print line. The largest number is largest. And we're not returning anything, and we should just be able to run this, assuming that I've wrote everything correctly. Let's get rid of this. The largest number is 100. Scanning this real quickly, it is 100. So real quick, let's just go over what they wrote here. They have a function to find the largest value in a vector, right? So we have our vector list here. I can just look at over here. We have a vector list here. Here we go at the top. And then to start off, we assign our largest variable, or we assign the current largest to be the first element in the vector, which makes sense because our largest needs to exist. It could have been 0, could have been anything. Just to be clear, I could make it 0 right now and that still works. We just need it set to something. By default, it's set to something, so that would still work too. And it still comes out to 100. And then we come down to this for loop, which is actually doing the work. So we're iterating over all the numbers in this vector, and then we're checking it against our current largest. And if any of these numbers that we come across is larger than our current largest, then we assign our current largest to be equal to that number. So we go through real quick. So 34, I put 0 here. It used to be 34, but let's go with 0. 34 is greater than 0. Our largest is now 34. 50 is greater than 34. Our largest is not 50. 25 is not larger than 50. So then our largest is still 50. Then we see 100. 100 is greater than 50. Our new largest is 100. 65 is not, so we skip over it. And then we print out our largest. And if I could spell correctly, wait, did I just spell it? Words, they just jumble in my head for some reason. Largest. Yeah, I spelled correctly. Well, I spelled it like they spelled it. And that comes to the end of the program. We just print out the largest number. So this is probably going to get abstracted out. This code stores a list of integers in a variable called number list and places the first number in the list in a variable named largest. Then it iterates through all of the numbers in the list, and if the current number is greater than the number stored in largest, it replaces the number in that variable. However, if the current number is less than or equal to the largest number seen so far, the variable doesn't change, and the code moves on to the next number in the list. After considering all of the numbers in the list, largest should hold the largest number, which in this case is 100. To find the largest number in two different lists of numbers, we can duplicate the code in listing 10-1 and use the same logic at two different places in the program, shown down here. So if we were to do this twice, what they're saying is you would more or less just copy this twice. And they did shadowing, so the variable names are the same. The only thing that's different is this vector, seemingly at first glance. So what you shouldn't be doing is what they're gonna. Ooh, I was meant to copy that. That didn't work out. Control Z. Copy. There we go. Paste, and this is us writing our second one. So we have 102, 34, 6,000, 89, 50. I'm not even sure if it matters at this point. They're all the numbers after 6,000 or less than 6,000. But the point they're trying to illustrate here is that since this functionality is not captured someplace else, we have to duplicate it if we want to use it again. Although this code works, duplicating code is tedious and error prone. We also have to update the code in multiple places when we want to change it. To eliminate this duplication, we can create an abstraction by defining a function that operates on any list of integers given to it in a parameter. This solution makes our code clearer and lets us express the concept of finding the largest number in a list abstractly. So yeah, bring this out into its own function. And that's what they do in listing 10-3. We extract the code that finds the largest number into a function named largest, unlike the code in listing 10-1, which can find the largest number in only one particular list. This program can find the largest number in 2 different lists. So let's do that real quick. Okay, a function called largest. Function largest. And has a list. That list is going to be a pointed to a vector that is of I32. And we're returning the value which is within it, the largest, which is I32. And we have to let mutable be largest. Ooh, I realized why we use the first element in the array. Because if we use 0, there's a possibility that every item in the list is less than 0, and thus we're returning an inaccurate result, because then we're returning 0 instead of what the actual greatest is. So yes, we should definitely use the first element in the list in the vector. And then for item, because they're all pointers, in list.iter, because we're going to iterate over it. I already have a 4. You don't have to give me. Hold on. They've added things for me, and I don't like that. For list.iter code block, if item is greater than largest equals item, and then return largest at the bottom. And now we should be able to remove this stuff. They just gave a result. Cool. Remove this. Let result equal largest and pass in number list. Oh, pointer to number list, right? And we do this twice. Control copy. Paste, and this is now a result. And so are you. So we still have some code duplication, but it's much less than what it was before. And this should still give us the same answers. 100, 6,000. The largest function has a parameter called list, which represents any concrete slice of I32 values that we might pass into a function. As a result, when we call the function, the code runs on the specific values that we pass in. In sum, here are the steps we took to change the code from listing 10-2 to 10-3. We identified duplication, which was the looping thing, this stuff. So that was identified. We extracted the duplicated code into the body of the function and specified the inputs and return values of that code in the function signature. So that part was the extracting. We made the code that we marked as duplication, made it the body of this function, and then we marked this function with the input that we believed we needed and the output that we wanted to return. Next, step 3, we updated the 2 instances of duplicated code to call the function instead. And the last step was using our new code, this function, in our existing code. So we removed all the duplication and replaced it with the function that we created. That is the steps to seemingly just refactoring in general. Next, we'll use these same steps with generics to reduce code duplication in different ways. In the same way that the function body can operate on an abstract list instead of specific values, generics allow code to operate on abstract types. For example, say we had 2 functions, one that finds the largest item in a slice of I32 values, and one that finds the largest item in a slice of char values. How would we eliminate that duplication? Let's find out. Hint, hint, generics. But let's move on and see what they say.